Alright, so I guess I'll take over now. So I'll start sharing my screen and you will be able to see literally everything on there, okay? So let us get started then. And let me know if you have any issues, if you cannot see anything or if you can't hear any audio, like me speaking for example, okay? But we will get started on the linked list part. So I am going to be doing this in a lower language called C language, okay? So, but I'll explain everything as I go, okay? So, as we proceed, so just an introduction to what a linked list is. So what is it exactly? Well, it's basically a list of nodes, okay? Each node contains a data portion and then the node pointer, which is holding the address that points to the next one, okay? If you want to visualize it, okay? Let's say I own a house, okay? And the house that I live in has a whole bunch of furniture, like TV, all that stuff. And then I have a piece of paper, okay? And this piece of paper has the address to the house that I live next to. And this piece of paper is the only place where I have the address listed, okay? So it's the only way for me to know what the address is in the next house, okay? And the one we're going to be going over today is a singly linked list, which means that it's only going from left to right, okay? Alrighty, anyways. Let's see. If there's anybody that's not muted, can you just please mute yourself? Thank you. Alright. I have a little diagram here to show people when it comes to linked lists. You start off with the head of the list, okay? We'll pretend that right now this is the only thing that we have, okay? You see the data portion right here, which is the value of 2. That's the data portion. And then the next one on the right, you see a little box that's having an arrow. That's the node pointer that's pointing next to the next list, okay? So the next one is going to be 45, then you got 3, and then it's pointing to null, okay? So you know that you reached the end of the linked list if the next portion of that last one points to null. So I can get started on the coding aspect, okay? And this is also going to be an introduction to also like programming in C as well. So let's get started then. Let me know if this font is too small for you guys to read, but I'll make it bigger just so you guys can see. You can see in my VS Code environment here, I got nothing in here. So I'm just going to create a new file name.c. And when it comes to C, okay, it's a little more complicated compared to just printing hello world, just a single line on Python, or printing like system.out in Java. I'll show you what I do in C. Okay, so we have to first include our directory. So we do hashtag include, and then left and right chevron, and inside there is going to be standard io.h. This is a library to do our standard in and standard out for like printing out the output, and also for taking in the input if a person wants to type something in for input for variables. So then we're going to create our main function, okay, or our main class, okay, our main function, call it that way. So it's going to take an int, it's going to return, that's the return value, it's going to be integer, okay, and then we'll type in main, and then in my parens, okay, integer argument counter, oops, and then a constant character pointer to argument vector, which is also an array, so it's a double pointer, and then return 0. This is what the default version of what it looks like for doing a C program, okay? And if we just want to print hello world, we just have to type printf, and then hello world here. Then / new line. So now you probably are thinking to yourself, what the heck is printf? Because I've never seen that before. It's usually like, just the word print. Well, in this case, printf just means print function, okay? The print statement here is also a function as well, which is included in the C library, okay, for standard io.h. Now, the next step is to have us compiling the C file. Okay, so we need to have a Makefile, and I'm doing this inside a Linux environment. Okay, so our Makefile is going to be what's going to run the program, and I'll do a brief rundown of what the Makefile is, but I can show you real quick of if we have GCC, and then we just have to do main.c, and you can see that we have a new file over here, .a.out. That's our executable, okay? So all I have to do is do, in a Linux environment, do a ./a.out, and we can see that it ran the program, okay? But I don't want to keep typing this whole thing out every time. In fact, I'm going to make a Makefile so that I can make it easier for me. So let me just delete this real quick. So then I'm going to start off with doing all, and then calling my executable main. And then our main is going to be depending on the main.object file. And then this is where all the complicated stuff starts. So I type in GCC, standard, C99, that's the language of C, the 1999 version. Then warning all, warning error, and then pedantic. And then .o, main.o. I'm just going to copy that line real quick because I'm going to need it again. So main.o, which relies on main.c. Just paste that in here, but I'm going to make a few changes over here. .-c instead, and then main.c. And then for clean, remove main.o. This is our Makefile, okay? And if I type make, oh, I misspelled it real quick. Hold on a second. Pedantic, not pedantic. Misspelled it. So if we type make, okay, you can see that we have the object file that is needed to create the executable, and now we have our main file, which is our executable itself. So we just type main. As you see, it works now, okay? Now, what if I want to delete all this, okay? I can just type in make clean. Henceforth, over here, this is the part that's going to be running the commands over here to remove all the files, okay? So everything is gone now. All right, so now that we have got that settled, so we can now get started on the linked list portion. All right, so when it comes to linked lists, we remember we mentioned that there's two parts to it, the data itself and then a node pointer. In here, we're going to be using a struct, okay? A struct with many variables in there, and we create the variable itself. So we're going to type in, before I do that, I want to create the node variable itself, predefining it before we use it, okay? Type def struct, oops. So node pointer, or sorry, node. And then we do struct node. And int data, that's where our data is going in, the numerical value. And then a node pointer next. And then we end up with a semicolon at the bottom. And yes, by the way, every statement that you want to run programs in, like, except the ones that you're opening and closing brackets, you have to always end with a semicolon. Just like Java, okay? You can see why this is similar. Anyways, let's say we want to create a new node, okay? Let's call this node pointer, and then we can call this head, the head of the list, okay? And then we can set head dot data equals to 12. Now, we'll pretend that, oh, what happened here? No pointer, okay. So, let me actually, it's not a pointer, just head. Because the reason why that brought up an error is because when I do a node pointer, it means that it's allocated memory, but I haven't done that. So right now it's just currently node. And then we do head.next, and that itself is a node pointer to set it to null. So if I run this, well, I'm getting a warning because I'm not using the variable itself, but if you pretend like this will run, then it should. So, but if I want to print this out, I send D, just a new line, and then head.data. But if I do this instead, it'll print out 12. So congrats, we just created the head of the list, okay? But I'm sure that if we want to add the next part, okay, I'll have to do something where I create the next node. I'll call this one first. Do.head.next equals to first. So that would all change. Then first dot data equals to 16. Oops. Then first equal to null. But the reason we're getting an error here is because I'm assigning a node to a node pointer, and that's not going to work. So I would have to literally have this become a node pointer. But now I'm having another issue now where I can't. First is undefined now, so then if I want to assign the data, because I would have to use the arrow operator if I have a node pointer. Oh yeah, my bad. Meant to. It's always the semicolons every time. So, but over here it says first.next must have union type, but has type no pointer. Okay. So I have to also change that as well. So that would solve everything out. So then if I print out the next part, it would be first arrow data. So then if I make this, it says first is uninitialized. In this case, I have to set this to null because it's a node pointer, and that would be why. So we can't use the uninitialized. So, and I get a segmentation fault. So, but anyways, okay. I think you guys get the picture of what a linked list is supposed to be. Do you guys have any questions at the moment? Alright, I guess I'll just continue then. So, back to, yeah, what's up? I can't hear you. Yeah, I can try doing that. Can you hear me a little bit better now? So. Yeah. Because the first I have to, because I'm storing it into a node pointer. I can't, because if you look at the struct over here, the node itself that's pointing to next, it needs to hold the address of first. Now, granted, I could just do this as a node first. I can keep it that way, and then if I set the head next to the address of first, that would also work too. So, and then I can change this all the way back to using a dot instead of the arrow, and that would work just fine. Although I gotta fix that as well. So, and then I can get rid of the null. That should fix everything. And there we go. That's better. that was my bad. So, let's see. What was my? So, anyways, going back to the slide itself, and continue on now. So, well, this is for later, but I had a video from Dr. Adams because he's my professor. So, I can get started with the part where it's whoops, with adding at the tail of the list. Now, if you guys know, if you remember me mentioning it earlier, okay, you're just adding at the end of a linked list. That's why it's called the tail. This right here, the last variable or the last node in the linked list is the tail. Now, this would require memory allocation. I can actually go over that right now. So, let's see, where is it? So, I'm gonna first go over real quick memory allocation. So we can just delete all that. So let's say I create a node pointer, and I'll do head equals null. Now this would require memory allocation, okay? So I would have to do, oh wait, not null, I meant node pointer. This is casting to the node type, and then we would use the command malloc. Malloc means memory allocation, so it's allocating the memory. And then now you want the size of it, okay? The size of node. And then every time we do this, malloc can fail if it fails to allocate memory, okay? So I have to do if head equals null, then I have to print out failed to allocate memory. And then exit 1. This is just forcibly ending the program, but we need another library for that, which would be standard lib. Yeah, because standard lib and it includes both the malloc and the exit functions here. So now that we have that, we can do the same thing with what do you call it? Like assigning the variable to both data and next. So when you allocate memory, by the way, and you're using a node pointer instead, you have to use the arrow operator, which basically means dereferencing, okay? When you have a pointer, okay, and let's say if you have like a int pointer address, I guess, and then I have like another integer over here, like int number equals 6, I would then assign the address, or assign the address of number into that address, okay? Let me get rid of that real quick. So. And if I were to print out the address and see what I get over here, well, shows as ls instead because it's not an integer, so it's like an address basically. I mean, it prints out nothing because I'm trying to print out an address, not a number itself. But if I were to dereference it instead by adding a star, because just like over here we use a star symbol over here to declare an integer pointer here, I also use a star for the variable itself to dereference it. So, okay. So then, by printing out the dereferenced address over here, I would get the value 6, which is pointing to the number over here. So, but enough of that. So, yeah, what's up? Because malloc is not guaranteed to allocate memory successfully. I'm not saying that it's going to, but every time you use malloc, it can fail. Not because it will fail, but it can. It would really depend on like the types of like, you know, devices you use, I guess. Like if you run out of memory per se, that would be the case where it would fail. I don't know if I answered your questions. Yeah, so. Now, just like the star operator for dereferencing a pointer, with the struct, you can also use the arrow operator to dereference as well. So I would have to dereference for data to reach that spot. And then I put in the number 12. And same thing for the next part, which I would set to null. And then if I print this out, %d/n, and then, let's see, head data. And if I print this out, it should print out the number 12. Now, considering that we've also allocated the memory, if we don't need it anymore, we also have to get rid of it. And that's where the free function comes in. You would free the head. And once that is done, it should run perfectly still. I mean, but there is a way for me to check and see if there are any memory leaks instead. I think in Visual Studios, there's like a specific way for like a header, like a CRT, something like that. But in a Linux environment where I'm using right now, I can use a command called valgrind. And if you see over here, you can see that all heap blocks are freed, no leaks are possible. But I want to show you what happens if I comment out the free and I leave it allocated. You can see that I lost 16 bytes in one block over here, and that's because I allocated the space for this, but I did not free it up. So every time you malloc, you also have to free it up as well. So. And that's precisely what the destroy function for a linked list, which we will go over later, is going to be about, okay? So, let's see. No, so we're releasing. I wouldn't necessarily say it stays in the memory, but it's just like lost somewhere inside your memory. So in a way, I think it does stay, but I don't know too much about that part. But it's just like you just kind of lost it. You just like lost it somewhere in memory where you can't even find it. So let's see. I don't know if I answered your question, but. Mm-hmm. Mm-hmm. Yeah. Yeah, I gotta. Mm-hmm. Alrighty, so I think I mentioned adding at the tail of the list. Let's write a function for that, okay? Alrighty, so let's see. I will basically, when it comes to writing functions in C, by the way, you have to first declare it, and then you have to also write a definition for it at the bottom of the main. At least that's what I do. So void, and by the way, void in C means that you don't return anything. You're just writing a function that doesn't return anything. So you would use the void keyword here. So insert at tail. I'm going to pass it by reference in this case. So you would have to put in a node pointer for the head, and then you pass in the data just fine. Now this part over here is called declaration. You have to declare it first. That's the thing with C, by the way. It's requiring a declaration before you also define it as well. I've seen people use it like where they define it up here, but preferably with the syntax and also good practice in C, you would also define it at the bottom over here. So I'm going to create a new node pointer over here called, I'm going to call it fresh. I don't know, that's just like a word that I like to use, so like a brand new node. So then inside it's going to be a node pointer, then malloc, size of node. And then there's a saying from Dr. Adams which I really like, which is every time you can malloc it can fail. So he would always have the class, like, you know, in using he would ask them every time you can malloc it can, and then the whole class says fail. So equals null. Oops. Then I'll just do exit 1. Now here's the part where we're going to be writing the stuff now. And before I move forward, I'm just going to I'm going to change all this, and I'll just change this to null instead. Oops. Because this variable here, the head that we define as node pointer, that's going to get passed into the function insert at tail. So the way we would call the function, it would be insert at tail. And then we pass in the address of head, and then the number we want to put on there, okay? And I'll get rid of that too. Well, I don't need either of these at the moment, so when we're defining it, let's see. Down over here. Notice how we passed in the number over here, and this is the new node that we are making, okay? The fresh variable, okay? We're gonna type in fresh, and then dereference it to data equals data. I'm assigning the data as one of the parameters for the function that's being passed through, and assigning it to the new variable of data over here. So that's got the data now, okay? But then for the next part, I'm just setting it to null. Now, do you all know why I'm setting the next part here to null? Anyone wants to answer it? Exactly. Because every time at the end of at the tail, it's always going to be null. So at least that's where the node is going to be pointing to. So now, what if there is nothing in our list? What if it is completely empty? What would you do here? Exactly. So I would put in here, I would do an if statement here, if, and always, by the way, if you're going to use head, you have to dereference it because it's a pointer. So dereference of head, if it's null, then set the head to the fresh, okay? Which is basically what we have over here. It's now the node itself, and we can just type in return over here. But assuming that now the reason why the return's over here is because you're finishing the use of the function, because the number that you just inserted, that's going to be the node itself. So that's all you have for it anyway. So, but let's assume that it's not empty, okay? Where is your head currently at the list? Because if I do a node pointer current, which is the current, okay, I'm sending that to the head, okay? How am I going to traverse through the linked list in order to reach to the end over there? Mm-hmm. Yep. Correct. Mm-hmm. Exactly. I'm going to do a while loop over here for current. And then for next, which is not equal to null. So it's traversing through while the next part is not null. And then current equals to current, oops, up next. And then at the end, we can just do current of next equals to fresh. So that's our insert at the tail function. So assuming that everything went correctly here, okay, this should very much well end up basically, you know, printing it out. So, but I also want to do. Oh, that's interesting. Yes. Anyways, because Pooja just posted in the chat about like the runtime memory, and if it does like stay in there somewhere. But good call, Pooja. You guys know how a for loop works, right? Because there's like this own version of for loops for linked lists. Because it's not a, I'm sure everybody knows, but in C you do like int I equals 0, and then the conditional I is less than size, and I++, that's the iteration part, and then like and then do this n times. You can see the structure of what a for loop looks like, right? So you're initializing the variable you're using over here, and then it's the conditional of when it's going to run for the for loop itself, and then the incrementing part. There is something similar that I do with a for loop in here for a linked list. Now, to start this off, okay, I'm going to do if head is not equal to null. And inside here is the for loop. For node pointer current is equal to head, that's the initialization part, okay? The first step. Then we have the conditional current, oops, it's not equal to null. And then current equals to current of next. That's the incrementing part. If it's not null, for which part? Is that the, because this part over here where I define the node pointer current is talking about this here, but it won't be null anymore because I'm calling the inserted that tail part now, so it won't be null anymore. But you're right, if, yeah. I mean, I can try that and see if it works or not, but I'm just gonna just paste that in here just so, I just like to make the syntax beautiful, I guess, so then I'll just do an empty print statement with a space over here so that looks good. But I can try to get rid of the if statement and see if that will make any difference. But let's see. I forgot to print out null over here. Hold on a second. Just giving you a better visualization for that, so. just see. Yeah, so you guys can see that, you know, we added to the tail of the list over here. No, so, and yes, you're right. I did not need the if statement there, so good job on that. Thanks for realizing that. Let's see. Let's say I do more numbers. Give me some numbers to add over here for the tail. And 1, and then 0. Yep. So then you can see now that we have a successful linked list over here. Damn, it's already 12:40. Well, I forgot to mention that this session, these like sessions on Fridays are usually an hour long, but just for the record, this might be a longer session, like probably like another 15 to 30 minutes if you guys don't mind, but you know. But I know you guys last time enjoyed Dr. Adams, you know, giving his like, you know, speech, I guess, like a month back. So I have a little treat for you. So I can just go back to the video here. You guys can watch this while let me just consider this our little intermission. Okay, so if you have to like, you know, go to the bathroom or something, you can go ahead and do that, or like get a snack. But I'll play this in the meantime.
Travel on a journey to Ohio, where they were having the tryouts to get a job at Disney. Like, I wanted to play trumpet at Disney World. That's what I wanted. I thought that would be a super cool summer job. And I went there, and I went in there with utmost confidence, and I did my little thing, and the guy didn't seem impressed with what I was able to do. And then he gave me what's called a sight reading piece. He gave me a sight reading piece, and he laid this music out in front of me, and it was a jazzy kind of piece. But on music, the notes as they climb up the staff get higher and higher and higher, and on a trumpet, when you're trying to play high notes, you squeeze it out. Anyway, there were notes on the sight reading piece that were notes I'd never attempted to play before. They were so high. They were like little squealer notes, and I was like, I can't play this. And he escorted me out into the hallway and said, "Thank you."
You don't hear him at all? I thought I it's because, yeah, I was trying to figure out what's wrong with the audio and stuff, because this is the first time trying to play videos while live streaming, but, you know, I can always just post a video in the chat as well if you guys want me to, so, because I have it on YouTube as well, so. Okay. This was just more of like, you know, how he felt embarrassed because we all did poorly on our exams last year, so this is more of like a break time thing, but you know. Wait, Pooja, are you able to hear it too or not? I don't know if she's in here or not, but yeah, so yeah, well, I'll just post it in the chat later, so. But anyways, moving on from that, we already discussed the adding at the tail of a list and everything, so. But now it's also adding at the head now, okay? This one's a little bit easier, and because all we're doing is we're just adding at the beginning of the linked list, so. Because like that part over here will be the head of the list, so. And then we'll talk about destroying the list for the last part, but going back to our compiler here, we would be writing a new function over here called insert at head node pointer. It takes in the same exact things. Just paste that. And let's see, destroy, oh no, sorry, insert at the head. So we would basically do the same thing when it comes to allocating memory for the new node that we're going to be using for fresh. Oops. And then every time you can malloc, you can fail, so yeah, so this one's a little bit easier when it comes to writing the function. Do you guys want to guide me on how I can do this? So do I have to create another one, or can I? Mm-hmm. Mm-hmm. Because we're passing it. Mm-hmm. For yeah, because mm-hmm. Right. So, because like when we don't have to traverse to the list because we already have the head being passed as the very first thing on the list, right? So, all I have to do is do fresh of data, which equals of data. That's basically the same thing as before. And then fresh of next equals to the dereference of head. And then I can just set dereference of head equals to fresh. That's all I have to do. So, and then let's say I add insert at the head. The head of, let's say 10. So assuming that everything worked out, okay, 10 should be the very first thing that shows up. So as you can see, we successfully added the at the head over here. Because it's much easier than the inserting at the tail, because at the tail you have to traverse through the entire list and reach at the end to find that the next equals a null, and then head is much easier for this one. So before I proceed on to the destroying the entire list, and I know there's two ways to do it, both iteratively or recursively. I'm probably just gonna go over the iterative version today, but right now at least I'm gonna just show you guys something when it comes to header files and creating another C file in order to organize stuff more, because this is very particular to compared to making a class in C, but in here we're just making a new header file and such. Because I remember when I was in a class with Dr. Adams, and he said that there was a guard, okay, who was guarding this table over here, and only he can see the inside, whatever's on that table, but nobody else can see it. Comparably to this, okay, we're creating another file over here in order to hide all the definitions in the code into a separate file. In this case, okay, I would create a new header file. Let's just call it list.h. I would first have to do an if not define, and then call this list underscore h, and then do a define as well, list.h, and then ending it with the end if. In the header file, this is where all your function declarations would go into. So I can just take all this, okay, and actually, in fact, I think I should probably also take the struct definition as well for our linked lists and insert it inside the list.h. So this is where it's going to be for now on. Now, I would create another file called list.c, and this is where all of our definitions will be going into. So you can also, you can see it's a much more simpler interface here now. So now, granted, okay, just like how we include directlies, like do include standard io.h and all that stuff, we can also do the same thing with including a header file. And also including the standard io.h, include standard lib.h. So considering that I did this now, everything should be fine. I also need to include the header file in this file as well. Now that would mean that we would have to make changes to our Makefile as well, which is going to compile everything. So first off, I'm going to need another .o file, another object file called list.o. And it's going to be depending on not just the list.c, but also the list.h. Oops. Oh, for doing a Makefile and like running it in a Windows environment. So it's obviously, you can see I'm doing this in a Linux environment here because you see I'm running Ubuntu on a Windows here. I'm using a program called WSL, which means Windows Subsystem Linux, but it's a little bit harder to do it in a Windows environment because you have to also like get all those like sorts of compilers itself, like GCC and G++, or like MinGW. And some of the syntax as well would be different on a Windows. Because like I'm sure I've tried it before on the Windows PowerShell. It's a little bit different because you would also have to install the regular Visual Studios, and then you have to go into settings like on your VS Code and change your compiler and everything to set it that way. And then like a little bit different with deleting all the files. It would be del instead of rm. But it's like, are you trying to also use a Makefile as well for all the files you're using? Okay. Do you have like the same kind of syntax I have here, or the same format as the Makefile as well? Because okay, I would have to see your screen yourself, but I can probably look at it later after the session if you like. So yeah, but But anyways, but I would highly suggest that you get WSL. Do you have a Windows 10 or 11? Okay, so getting WSL is actually very easy for you then. The setup is actually not that bad. I think because you have Windows 11, you already have it set up. So if you go to the App Store and you download Ubuntu itself, and then you can open that up and by clicking the Ubuntu icon, it'll ask you to okay. Because really, yeah, it's all good. Because I had the same struggles before when it comes to setting this up until I was successful at it. I'll tell you this much though: using a Windows 11 is much easier with WSL because everything is already set up for you. So compared to Windows 10. But yes, there's a little thing about Makefiles here. I can also simplify this a little bit more. So I can do definitions like CC equals GCC. So then I would replace all these with a $sign and then parentheses, just like that. And same thing with all this entire stuff over here. I call the C flags. For Makefiles, because all you do is, there's typically no extension for it. It'll identify itself by if you just name it Makefile here, if you can see right here. Just like how my VS Code already identify what it is. So yeah, there really isn't no extension for it per se. It'll just identify itself as Makefile. That's from what I've done. And I think the command for also running it in Windows is also make, but it's a little different with Windows than Linux. So now, if I want to replace all that stuff, I would just do C flags over here. Everything should run as normally as well, so I can just get rid of all that port and replace it with this. And since we have multiple .o files, I can just do a star.o instead. Oops. Which means that, hey, when I always run the command make clean, I want you to delete all the .o files that have been produced by making. So assuming that everything is good over here without any errors, everything should run. Oh well, I used the close brackets by accident instead of quotation marks. So, and then now it's saying cannot find list.o. So it failed to produce list.o. So going back to my Makefile. Let's see. It says Makefile list.6. Oh, that's why. I did not delete that part. And now it's saying it's still doing the same thing. I want to make sure that my autosave is on too, so. You gotta love coding, huh? Finding errors as you go, so. Let's see. I gotta check over here real quick. Making sure that. Let's see, let's type H. Let's see. Line 7. Oh yeah, that's right. I meant to do list.h as well here, so thank you for that. Okay, well, it's still giving me errors over here, which is weird, so let's see. Oh yeah, I also forgot to add it as well over here in line 5, that's why. Okay, there we go. So everything should run nice and smoothly. This is just a better way to organize everything so that I don't have to worry about, like, you know, having one huge file over here too. So we can finally move on to the deallocation part. And I'm just going to call this part void destroy list. And all we have to do is pass in a node pointer head. And just adding it down over here. Do you guys remember what operator or like what function we use in order to free up memory? Correct, yes. So we're going to use a loop in order to free up all the memory. Now this is going to be the iterative way. There's also a recursive way, which I have not tried yet, but I'll just show you the iterative way. So I would just have to do node current equals head. Now, if you think about it, okay, I'm having the current, you know, iterate as I go, and I also need a new variable called like temporary, for example. That temporary is going to hold it and then ends up destroying it, so that it can also hold the next part and also the part where it wants to destroy it. Now, I would show you a video from Dr. Adams for this, but as you see, there's like an issue with audio, so I feel bad that I can't show you guys it. Thank you, Pooja, because she has to leave, but you know. Anyways, so we will create the while loop now for deallocating the whole list. It's not equal to null. Create a new one called temporary, or just temp, equals to current. And this is a part that's going to be getting destroyed, okay? I need to hold it somewhere so I can destroy itself, and then also have the next part so that I can access it again. So current equals current of next. And then we can also free up the temp variable as well. So then afterwards, we would just have to call it once. Let's see. Oops. So then destroy list, and then passing in the address of head. Now I'll just show you real quick once again when I run Valgrind what would happen if I, well, let me type first make. You can see that we had a whole bunch of stuff that was lost in memory, but if I run this, everything should get freed up. Oh, I either misspelled something, or I wonder if it's somewhere here that I, oh yeah, spelling errors. So you can see that everything was freed up and no leaks are possible, so that's how you destroy a linked list as well. I hope this gave you a better understanding, at least in the C language, on how to do a linked list, because let me tell you, okay, all the other sorts of like DSA algorithm stuff, it's all possible to do in C as well, okay? Just as like, you know, some of the sorting definitions like quick sort, bubble sort, insertion, selection sort, I've done it all in C before as well, so, and also like other sorts of data structures like vector and like, you know, stacks and queues, which by the way, we would have to do the same thing with creating like a separate .h and c file when it comes to vector. Because like vector and like Q's and sex don't exist in a low-level language just as C. But we all did it in class where we made it separately. So I hope this visualization itself gave you a better picture of what it's like to do data structures or algorithms in C. So I don't know if you guys have any questions, but feel free to ask, okay? So if you guys don't have any questions, then, you know, that's the session for today. So Pooja's not here now, but it was absolutely an honor to do my own session today on the server. So just want to thank you guys for joining, okay? Yeah, absolutely. I'll probably do it again in the future. I don't know when, but you know, if I have time. So that'll be it for today's session. Again, thank you very much, okay? Someone's typing the chat, so I'm just waiting to see. Oh yeah, I can share the code, yeah. I'll just have to figure out where the code needs to be shared on the server. Maybe we'll create a new channel for that. And yes, this is recorded, so I can share the video as well. So it'll be posted on my channel. So, but other than that, you guys are free to go then, okay? So once again, thank you. My channel's called, I'll type it in the chat here. That's my channel. So you'll be able to find me if you search that up, so. And those are other places where I have posted the videos, like with Dr. Adams and stuff. With like, you know, that, you know, speech he was giving, so you'll definitely find it on there, okay? Yeah. Because, like, I was gonna mention this where also at adding the head and also the tail, there's also, you know, other ways to do it. Because, like, I did it by reference, but there was another way that Dr. Adams did it, which he showed, but I have to find that, so. But, yeah, that's all it, okay? So, it's been a pleasure, okay? All of you have a great day, okay? So.